we're looking at the congruent figure test review. Number 1 says the vertices of triangle STU are S at 1, negative 2, T at 5, negative 2, and U at 1, negative 4. Find the coordinates of the image of triangle STU after a composition of the transformations in this order. First, xy maps to negative x, negative y. Second, reflection over the y-axis. So what I did first was I just copied down the ordered pairs here on the left. Right. If you want, you can end up graphing your shape. I added the actual graph here for you to use if you need to. Alright, so if you were to graph, you go right 1, down 2 for S, right 5, down 2 for T, right 1, down 4 for U. Now, the first transformation ends up taking xy and mapping it to negative x, negative y. So what's actually happening here is both the signs become their opposite. So for s at 1, negative 2, it would become negative 1, positive 2. Noticing both of the signs end up becoming the opposite of what they originally were. T becomes negative 5, 2. U becomes negative 1, 4. So if I actually graph those points, you see them here in the upper left quadrant, which is quadrant number 2. So going from the original to that quadrant is actually a rotation of 180 degrees. Now for the second transformation, it says a reflection over the y-axis. So I could use this graph, count how far it is to the left, and then just move it that far to the right of my y-axis to give me my new point. I would do the same thing for S, and could do the same thing for T. Now, also you can remember the rule for a reflection over a specific axis. That is, whichever axis you're flipping over, value stays the same, the other one becomes the opposite. So if I use that rule and just continue on here, negative 1, 2, well, the 2 has to remain a positive 2. The negative 1, however, becomes a positive 1. We do the same thing for t, making it 5, 2, and the u making it 1, 4. Now again, we also could have just looked at our graph and gotten that as well. Now, again, this is actually wanting the coordinates for it, so just graphing the picture is not going to be enough. We need to actually give the coordinates. Since I did 2 different transformations to get to where I'm going, this is not going to just be a prime, this has to be a double prime. So S is at 1, 2. T is at 5, 2, and U is at 1, 4. And again, since those are all after 2 transformations, they have to be double prime. Now number 2 wants to know, is there a sequence of rigid motions that maps triangle ABC to triangle PNM? Explain your reasoning. Alright, so first off, the one thing that you want to notice about here is the letters. So ABC maps to PNM. So if you look at A, it has to match with the first letter on the second one. So A is here, moving down to P, which is on the bottom. Now, if you notice how this looks, okay, B and N obviously have to be the same, but A does not necessarily map over. I couldn't do a flip over here and then slide down, because if I did that, A would be in the same location as M, which is not the order that we are looking for here. So I need to actually get A down to the bottom and kind of keep the same order of how the triangle is looking. So in order to do that, I'm going to actually have to turn this figure. So this is a rotation of 90 degrees, moving it down from quadrant 2 to quadrant 3. Now, if you actually turn your paper, you can see where these points end up lying. R, you can end up remembering the rule for the rotation of 90 degrees. Now, if I just turn my paper, C would be at -1, -2. B would be at -4, -2. And A would be at -4, -5. Okay, so these are all the locations of the original triangle after doing a 90-degree rotation. Now, in order for me to say that these two are congruent, however, they have to actually be overlapping. Now, even though they obviously can tell that they are the same shape, they're not overlapping yet because one's here on the left, the other one is still on the right. So in order for me to get those overlapping, I just need to do a translation 6 units to the right. You can count 1, 2, 3, 4, 5, and 6, and A overlaps P. All these other points would overlap at the same time. So in order for these two triangles to be congruent in this specific order, we would have to follow this rule of the 90-degree rotation and a translation 6 units right. Now, however, there are other transformations that could possibly get you this answer. Again, as long as you get to the correct answer, you will be fine. Now let's look at number 3. It says if triangle ABC is congruent to triangle GHI, what is the length of segment GI? So again, the order does matter with these different congruence relationships. GI is the first and the third letter. So we have to match it with the first and the third letter again, which happens to be AC. So if we look at AC on the triangle, we have it being the length of 10. That maps to the same thing GI, so that would also be 10. So your answer for GI would be 10. Now, we can do the same thing with number 4. It says name the triangle that is congruent to ZYX. So again, if we're talking about triangles being congruent, the order is very important. Z is the same as S because if you notice they have 3 arc marks inside of it. So Z and S have to be the same. Y has to be the same as Q because there's 2 arc marks. And X would have to be the same as R because there's only one in those. So we have to go in the exact same order whenever we're doing the one. So we started off with Z, so that's S. Then we went Y, so that is Q. And then we went X, so that is R. So S, Q, R would be the triangle that would be congruent. Alright, so now for number 5. In the figure below, triangle ABC is congruent to triangle MPN. Find the length of segment AB. Okay, so we're looking for AB, which is the first and the second letter in triangle ABC. So we go with the first and the second letter in triangle MPN. So MP has to be the same as AB. MP we have is 4.5. So that means that AB is also going to be 4.5. Alright, so for number 6, in the figure below, triangle FGH is congruent to triangle RST. Find TR and measure of angle S. So again, TR is the third and the first letter. So it matches with the third and first letter, which is HF. S is the second letter, so it would match with the second letter, which would be G. So when we're matching this together, HF would be the same as TR, so HF we have is 7.2, so that means TR is 7.2. S matches with G, which is 73 degrees, so that means S is 73 degrees. Number 7, in this figure below, triangle ABC is congruent to triangle MPN. Find the measure of angle A. Again, A is the first letter, which matches the first letter. So, A matches with M. M is 27 degrees, making A 27 degrees. For number 8, a figure lies in quadrant 2 of a coordinate plane. The figure is transformed by reflecting across the x-axis and then rotating 270 degrees clockwise about the origin. In what quadrant will the image lie? So, what they have here is they drew a pentagon in quadrant 2 to represent this figure that they were talking about. Now, does not really matter what figure it is, we're still going to follow the same thing. The figure is exclusive to quadrant 2, so it's only going to be in this upper left corner. So when we do a flip over the x-axis, if it's in the upper left corner, it now would flip into the bottom left corner, right, which is quadrant number 3. So we did the flip, it would move into this quadrant here, quadrant 3. Then the second transformation is rotating 270 degrees clockwise about the origin. So we're going to take this figure that we know is already going to be in quadrant 3 and move 90, 180, 270 degrees into quadrant 4. Okay. Now, that is the bottom right quadrant. Okay. Now, luckily on these problems is you are given the letters are the Roman numerals for each quadrant. So you have 1, 2, 3, and 4. Now, you have it given to you, but just to remind you, this is how you would end up finding it if you did not have the letters. You can just make a C going from the quadrant at the top right all the way down to the bottom right. And that is the order. So 1, 2, 3, and 4. But again, it was a flip from quadrant 2 to quadrant 3, then 270 degrees clockwise, which means we're turning to the right, and that gives it into quadrant 4. When we name our answer, we need to still keep the Roman numerals. Number 9, in trying to decide if the left and the right pentagons shown are congruent, Beth used the following reasoning. I reflected the left pentagon across the y-axis, then translated 1 unit down. The figures did not line up, so the figures are not congruent. Explain and correct the error in the reasoning. Okay, so here's what she actually did. She takes the figure, she does a flip, so we end up getting this blue figure here. Then she slides it down 1 unit, so we get this figure here. Right? Those two, as she does describe, do not line up. However, the problem with that is that does not mean that these figures are not congruent. Whenever she did this, she just went the wrong direction whenever she was doing a translation. Instead of translating 1 unit down, she should have translated that figure 1 unit up. What she was describing was if she was going from the right figure to the left figure, then that would be the way that you would work it. But in order to explain this, we just need to say she translated wrong. She needs to translate 1 unit up instead. Now, again, question might be a little bit different on the test. Just read carefully and make sure you end up knowing what exactly Beth has done on the problem to get the conclusions that she does. On number 10, it says, in the figure below, triangle ABC is a reflection of triangle ADC over the line AC. Explain why angle angle D is congruent to angle B. So they're saying that angle D is the same as angle B, which would be correct. Alright, but there's actually a real logical way we have to explain it. We have to use the rules that we've actually been talking about in class. The only way that we know things are congruent is if you can map it with a rigid motion. So, they give you enough information to say it. Now we have to include all 3 of these in order for the question to be exactly correct. So, first is, a reflection is a rigid motion. Rigid motions then would mean that it creates congruent figures. So the figures are congruent to each other because we know that the reflection is a rigid motion. And then the last one, we can use the shortcut abbreviation CPCFC, which means corresponding parts of congruent figures are congruent. Now this is just a quicker way of writing in that because we know that those two figures are congruent, that the parts that match up have to match up together. So saves you a little bit of time writing it, and you get CPCFC. That just means that those corresponding parts are congruent to each other. Alright, so for number 11, it says tell whether a rigid motion can move the solid figure onto the dashed figure. If so, describe the transformations you can, or that you can use. If not, explain why the figures are not congruent. Alright, so we take this first figure and we have to move it here. This line matches up with here, so it looks like it's a rotation, and in fact it actually is a rotation of 180 degrees. So that is a rigid motion, so it does make it congruent. So our answer here would be rotation of 180 degrees. Now that is not the only one that you could have done. You could also have flipped over the y-axis, then flipped over the x-axis again, and it would line up the same way. Now again, there's multiple ways to do these types of problems. As long as you get one of the ways that would be correct, and that would be fine. Now, note on the test, sometimes these lines end up coming off printed wrong, but all of these lines are supposed to be straight. Now we can also just look at number 12 real fast. We're looking at if triangle ABC is congruent to triangle DEF, which segment is congruent to segment FE? So if we look at it, FE is the third and the second, so we match for the third and the second, so it's going to be segment CB. Now we have number 13. It says draw the result of a reflecting draw the result of reflecting the figure across the y-axis and then translating it along the vector -2, -4. So we take the original figure and we do a flip over the y-axis. So x was 1 to the left, moves 1 to the right. Z was on the line, so it still stays on the line. Y was 2 to the left, so it moves 2 to the right. Connect those, we get this triangle x prime, y prime, z prime. Then we have to translate it along the vector -2, -4, which just means left 2, down 4. So each of these points, we're going left 2, down 4. Here's my new x. Left 2, down 4. Here's my new y. Left 2, down 4. Here's my new z. Again, it wants you to draw it, so we don't have to put the ordered pairs. We just have the figure drawn. Okay. And now we're to the last problem. It says triangle XYZ is reflected across the y-axis, then its image is rotated 90 degrees about the origin. What are the coordinates of the final image of point Y under the composition of transformations? Alright, so the first thing I noticed whenever I was looking at this is that we're only worried about point Y. So X and Z don't really matter. We don't have to worry about doing those parts of the triangle. We're only focused on Y. So the first thing was a reflection across the y-axis. So if I'm going to go across the y-axis, it was 1 to the right, moves now the y prime to 1 to the left. So here's my y prime at point -1, -2. Now, if we're rotating 90 degrees about the origin, we're just going to take that paper, turn it 90 degrees to the left. Again, we're going counterclockwise, so we're going to the left. And when we do that, it moves it to this point here at 2, -1. Again, we've done 2 transformations, so now it's y double prime, and that point is 2, -1. Alright, so we've now finished the review. Everybody, make sure you go home, study, and be ready for your test tomorrow. Good luck, everyone. Bye-bye.